says, what is the length of the arc? What is the length of the curve, this thing right here? Arc length is a formula. It's the integral from a to b, and this is your a to b. ds is the square root of 1 plus dy dx squared.
Okay.
So in short, you have to take the derivative of this, y prime, which is dy dx. So that is power rule. You bring that 3/2 down, subtract 1 from the exponent. Okay, and if you simplify that, this obviously cancels. Okay, and then you square both sides.
Okay.
And the nice thing here is when you square an exponent, you multiply them. So this becomes just x. So your integral works out really nicely. And that's one of the things I want to mention here is that you're probably there's not that many options here for them to give you. You probably will only get something that works out nicely, or it'll just say set it up, or it'll say, put in your calculator.
Yeah.
This right here is a U substitution problem. Your U is 1 plus x, du is dx, and we might as well change the bounds. So we'll put 0 into this function for u. 1 plus 0 is 1. U of 3 is 4. So that changes your limits of integration.
Okay.
It's the square root of u, and then dx is du. So if you need to, you can rewrite that as u to the 1/2, but you're going to find the antiderivative of that. U to the 3/2, 2/3 out in front, evaluated from 1 to 4. So that's 2/3, 4 to the 3/2 power, minus 1 to the 3/2 power. And 1 to any power is always 1.
Yeah.
4 is 2 squared to the 3/2. Just like before, exponent of exponent, you multiply, so that's 2 to the 3rds, that ends up being 8 minus 1.
Okay.
And you still have this 2/3 on the outside. So that's 7, 14 over 3.
Okay. Awesome.
All right. So it looks like 10 is already done.
Yeah. That one in class.
All right, so we're on to, is it this question says 2002 BC2?
Yeah.
Okay.
This one?
It's just a slight delay. I have to download and then rotate the image, and then I'll get it on there. So, okay. You mentioned something last time about not doing AP questions. This is probably, I mean, it is. It says it was on the BC part of the exam.
Mm-hmm.
Is that still okay for us to do?
Yeah, we can try it.
Okay. All right, so I tend to just, as a test taking strategy, I tend to just go right to the question here. How many people entered the park by 5 p.m. T equals 17? Entered the park is up here.
Mm-hmm.
Oh, that's rate. They're giving you rates. So rates you have to integrate to get totals. And if we integrate the number of people, the rate at which people entered up to 17, starting at 9, because they start at 9 there, that'll tell us how many people have entered. Now, one of the things we don't know is how many people are in the park to start but it does say no people in the park to start. But if there were, like if there were a special event and people are there already, you would add that out in front.
Okay.
So this is 9 to 17. And then you're doing this E of T function, 156, 15,600 over T squared minus 24T plus 160 DT. And it wants you to round your answer to the nearest whole number. So if you got a calculator, go ahead and grab it and see if you can work this out. I'm going to also enter it into a numerical integral thing and give you my answer.
Okay. Perfect. Sounds good.
Okay,
Yeah.
so moving on to part B.
Yeah.
Let me see what part B says. Price of admission to the park is $15 until 5 p.m. After 5 p.m., the price of admission is $11. How many dollars are collected from admission to the park on a given day? All right, so the 6,004 is the number of people that entered before 5 p.m. We got that from the previous part. So we can just multiply that by 15 plus $11 times the number of people that entered after 5 p.m. So that's from 17 to whenever it closes, and it closes at t equals 23 or 11 p.m. And it's that this next part here.
Okay.
And if you want to grab your calculator and come up with these, I'll get the individual numbers and then you can piece them together if you want to look back at this later.
Okay.
Okay, so I get 104,000 as the final.
Okay. Almost there. Yep, I got that too.
Okay. All right, let's look at part C. Let h of t equal the integral from 9 to t. So 9 is when they open until sometime later in the day. E is a function of those that enter and those that leave the park from 9 to 23. And the first thing they want you to do is find the value of h of 17. Okay, and they sometimes ask this another way. They just say, how many people would be left? Basically your rate in minus your rate out integrated at a certain time. Oh, I'm sorry, they give that to you. Sorry, they give you, I didn't realize they give that to you. They give you that number, so you don't have to do it. Okay. And then they want you to find the value h prime of 17. Okay. All right. So to do that, to do h prime of 17, this is like one of those fundamental theorem of calculus things. So you put the upper limit in each of these. So h prime of 17. Well, let's first do h prime of t. I'm sorry, let's do h. Yes, h prime of t is e to the t minus L. I'm sorry, L e of t minus L of t. But then you're supposed to multiply that by the derivative of the upper bound, which is 1. But so let's let's do that. Find the value. Okay, so h of 17 means e of 17 minus L of 17. Okay, and you go back to your functions. So e of 17 means to put 17 in for t in that first thing that it gave you, 17 squared minus 24 times 7 plus 160. L of 17 is 9890 over, oh, they're not the same. 17 squared minus 38 times 17 plus 370. Okay, so let's get that number.
Okay. That's what I got.
All right. So the h prime of 17 is a rate, and you need to go back and look at the what the rate definition is in terms of its units. So it's the number of people per hour.
Okay.
Because it wants you to interpret as part of the answer. So you would say, if you go back and read it, it says, let's see, where does it say that? It says, explain the meaning of h of 17. So you would say at 5 p.m., that's 17, the number of people in the park is 3,725. That's the given value. That's the h of 17, and is decreasing because the derivative is negative.
Yeah.
By 380 people per hour.
Okay.
And you may remember this. If it's negative, you say decreasing. If it's positive, you say increasing, and then you just take the number. So it makes sense. You would think people would start leaving then.
Yeah.
It's probably why they do that.
Mhm.
I guess.
Okay.
At what time for t 9 to 23 does the model predict the number of people in the park is a maximum? So to do this, you have to look at E of t minus L of t.
Okay.
Okay, and let me write it out here, but you would probably use a calculator for this part. So I'm going to graph it if you're okay with that.
Yeah.
So this is the derivative, and you basically care about where does the derivative equal 0.
Yeah.
And what you're hoping to see is what is this asking for? It's a maximum. What you're looking for is the derivative. Let's see here, decreasing. So where the derivative goes this way, because it goes from, I'm sorry, goes this way. It goes from positive to negative. And so let me quickly graph that so you can see what it looks like. Have you thought any more about taking the AP, or is that completely off the table?
It's off the table. More just so like I don't want to be done with finals and everything and still have AP tests to take. And none of
Yeah.
the colleges that I applied to were like, we'll give you more money if you take one, or
Yeah, I understand. There's just me just
Yeah.
asking, just curious.
I'm not a good AP tester.
Yeah.
Like I just don't click with APs.
Yeah, well, there's a lot to be said for whether testing is done correctly. All right, so let me snip this in, and you'll see what we care about here. Actually, I didn't get the point that I wanted. Let me just grab one more snip.
Yeah. All of my classes this year are AP, and I'm only taking one of the tests, and it's studio art. So it's just the art I've been doing all year. So
Cool.
no tests for me at the end of the year.
Hey, there's no requirement. They don't say you have to take it. So
Mm-hmm.
again, this is the derivative. It is not this point. No. Is
Okay.
this one down here? Yes, because the derivative it has to change sign from positive to negative.
Okay.
So this is your t value that they're asking for.
Okay.
And all right, you say that, except to just say I graphed it. Here's a picture of the graph, and
Yeah, I'll probably just draw a picture because it says calculator okay. So I assume we'll realize people will graph it.
yeah, if you could take a derivative by hand, but you would still have to. This does not work out nicely.
Yeah.
It's designed that way, like it's not meant to be done.
Yeah.
In such a way. Okay. If you understand that, that's great.
Yeah.
We have let R be the shaded region kind of thing here. Does that look right?
Yeah.
The next one?
This is the last one. We're going fast.
Yes. And we only need to do part A. Is that right?
Yeah.
Okay.
Oh.
Your handwriting is very good.
Thank you.
Do you do any tablet writing or writing on a tablet or like an iPad or another student, art tablet, or is it
I
all?
want to get one, but I just haven't had the time, but I don't.
Believe it or not, I'm using a product from Wacom, WACOM. It's a tablet pad thing that people use that are artists. I don't claim to be. You may just consider them. I really like their product. I don't get anything from it also. So this is purely just me telling you what I like. So
I'll look into it because iPads are expensive.
they sure are. This was less. All right. Let R be the shaded region in the first quadrant enclosed by the y-axis and the graph. So there's a lot of things that have already been drawn here. So let me just make another quick sketch of this. This is R right here.
Mhm.
And so the first thing you really need is that intersection point, which you found is pi over 4. So the area is the integral from 0 to pi over 4. It's top minus bottom. And the top here is cosine x, bottom is sine x. It's an area, so you don't have to do any revolving. And that's it. You do have to find your antiderivatives here. Antiderivative of cosine is sine. Antiderivative of sine is minus cosine, so we can change it to a plus. And you evaluate from 0 to pi over 4.
Okay.
Make sure that's right. Looks okay. Okay, so you got sine pi over 4 plus cosine pi over 4 minus sine 0 minus cosine 0. Oh, this is another technique. You can also just start subtracting the lower bounds. You don't have to put it in parentheses. Maybe you've already been doing that.
Yeah.
So these are just straight from your unit circle. It's that nice 45 there, where they're the same. Sine is 0, 0, cosine of 0 is 1. So you get root 2. So root 2 minus 1 as your final answer.
Okay. Nice. Makes sense.
You also write really small, which is really impressive.
I use a 0.3 pen.
Yeah, and your pressure must not be real high either, because it's that's fine lead. Boy, it's tough to do.
Yeah, that was okay.
All right.
That's all I have. I'll find more stuff to do for Sunday.
Okay. Are you sure? Okay. I mean, we're happy to hear.
Anything else? I thought that would. I don't know. I thought that would cover. I underestimated.
All right. Well, thank you so much. I'll see you next time. You said we got a lesson on Sunday, so see you then.
Yeah, I'll find more stuff.
Sounds good.
Thank you.
Bye now.